How do I create new storm and foul networks? This video will demonstrate how to create new storm and foul networks using a graphical user interface embedded within AutoCAD, including AutoCAD Civil 3D. Smart Drainage is a smart tool that will automatically translate a plan view of a drainage layout constructed from standard AutoCAD graphic entities into a network of nodes and links ready for Causeway Flow to design and analyze. The network may be drawn specifically for design with Flow, or as a project drawing, or maybe a legacy CAD drawing. Smart Drainage is very versatile in interpreting the CAD structure of drawings. The user has only to select the outfall node of the CAD drainage layout to translate it into a Flow network. Smart Drainage finds the connected nodes and links, their cover levels and catchment areas. After analysis in Flow, Smart Drainage annotates the plan layout, draws long sections and schedules, and creates 3D BIM models. In this video, we will assume we are creating the drainage layout for new design, but the same methodology would apply for legacy drawings. To save time, we have already drawn most of our network, but we will demonstrate how you can create some components too. Let us start the design by drawing our network of nodes, links and contributing areas from standard CAD entities. We can use lines, polylines or arcs to draw the links. In this case, we will use polylines, which are the most versatile because they can include multiple straights and arcs to show the true shape of the link, perhaps running parallel. Each link must have a separate entity, so stop and restart polylines at each node. On complex bifurcating networks, draw the link in the direction from upstream node to downstream node. This will ensure that Smart Drainage connects it correctly. Smart Drainage can use the layer name and/or line type to recognize the flow link type automatically. Please refer to the video How do I create and load a manhole and pipe library for more detail. To draw a node, you can use circles or block references. Here we use both types. Polylines are used to draw the contributing areas. To cope with different working methods, there are choices on how the area is assigned to a node. If the boundary polyline is open, both ends must be nearer the same node than to any other, and within a distance tolerance. If it is closed, the area goes to the single node inside it. If there's more than one or no nodes inside it, the area goes to the node that is nearest the boundary and within the set tolerance. Multiple catchments with different impermeability factors may be assigned to the same node. Now we have drawn our network, we have the option to select a smart surface to give the cover levels and ground profiles. We will choose a multi-surface and select the one we want from the drop-down list. If there is no current smart surface, the form shows none. If you would like to learn more, please have a look at the video How do I create a smart surface for more detail. Smart Drainage embeds the flow data within the AutoCAD or Civil 3D file, complete with all its non-graphic information. This keeps graphics and analysis within a single file of a type handled by major document management systems. To create a new network, we first need to go to Network Manager, choose whether it is to be a storm or foul network, and enter a unique name for it in the text box. For this example, we will create one network of each type, but you can make many networks in the same file where it suits the project to do so. Flow and Smart Drainage also support multiple outfalls in a single network, so long as the design parameters are the same for all its parts. Smart Drainage is suitable for all sizes of design team, from a single designer right up to global joint ventures. After giving the Storm network a unique name, we click the Add button. The button is enabled only if the name does not already exist in this drawing. While we are in the Network Manager form, let us look at the functionality available. The Delete button removes the flow data for the chosen network and any generated output, such as long sections, while leaving the layout intact. Smart Drainage asks for confirmation before deletion. The Rename button updates the flow data and generated output to the new name. The button is enabled as long as the new name is different from any network names already in the file. Smart Drainage adapts to the user's CAD standard or drawing structure through the Network Settings form. These settings are stored separately for each network and also update the default settings that will be applied to any new network that is created. Smart Drainage maintains separate defaults for storm or foul networks, for example to set different layers for each type. In this instance, we will accept the current settings, but if you would like to learn more about network settings, please look at the video How do I create node, link and catchment masks? We click the OK button to accept the default settings. We are now ready to build our network. The build update command finds all the connected nodes and links in a network by working upstream from the outfalls. The first time a new network is defined, Smart Drainage asks the user to select the outfall node, which must match any overall masking and entity types defined in the node settings for this network. Subsequent build update commands use the previous node coordinates from the internal flow file to find and annotate the updated layout. Once we select the outfall node, Smart Drainage will build the network. At this stage, it does not yet have any information about the pipe sizes, slopes, or any design information. However, it will build a network ready to be exported to Flow for the design for conveyance and hydraulic performance. Smart Drainage shows the overall status of the current network as a traffic light. Blue is undefined, red means a validation error, including incomplete design settings that must be entered in Flow. Amber means that Flow has generated warnings, and green means that the status is good. Hovering the mouse cursor over the status icon will show this explanation. But before we export this file to Flow, let's also build the foul network. If you don't need a foul network, you can export your file at this stage. To build the foul network, we will follow a similar process as for the storm network. We already have the network drawn, so we open the Network Manager, select Foul, give a unique name, and close Network Manager again. Build the foul network by selecting the outfall node, just as we did for the storm network. The build update command also applies any revised annotation styles for nodes and links, which may be customized for each network if required. Now we have both storm and foul networks ready for export. Let us select the Export to Flow button and give our file a unique name. We can now open the file we created with Smart Drainage in Flow to conduct our conveyance design and hydraulically test our storm network for extreme events. Please visit our website, the help file within Flow, or watch the videos on our YouTube channel if you want to learn more about Flow. As our focus here is Smart Drainage, we will deal with a very basic design process only. We must first specify our design settings parameters and optimize our network. In the nodes table, we see that our nodes already have coordinates, cover levels, and contributing areas. The levels were automatically picked up using Smart Surface, but you could also use the CAD entity levels if available to achieve similar goals. The links table shows that Smart Drainage has populated the end nodes, lengths and link types. The profile shows the ground levels along the links, again made by Smart Surface. As you can see, we have all the necessary elements that constitute a network. All we need to do is optimize our network based on design capacity and minimum cover depth. Notice that the Plan View option shows the networks because they already have the coordinates imported from CAD. You can zoom and pan in this view. As you can see, when we hover the mouse over the elements, a pop-up display provides an information panel. Now let us look at introducing flow controls. We will introduce a hydro break optimum by specifying the design depth and design flow to determine the diameter based on the model you choose. Flow is also configured to make sure that the right sized manhole is used to fit the hydro break model you select. We will also introduce an appropriate storage size to store the water that will back up in our network. Because the storm and foul networks cross each other, we can use the Show Crossing option to display the crossing point on the same long section. For the foul networks, we specify in our design settings that we want to optimize the network based on a 0.75 meters per second self-cleansing velocity for a 1/3 capacity flow. Because the storm and foul networks cross each other, we can use the Show Crossing option to display the crossing point on the same long section. And now, back in the storm network, we are ready to set up our simulation settings and run the hydraulic simulation for extreme events. For more details about how to use flow, please refer to the examples in the help. Once the flow file is updated with our design, we will be able to import it back into Smart Drainage